when we talk about the matrix methods for simultaneous equations, everybody's familiar with the linear simultaneous equations. You all would have seen these things in Form 3. You all would have learned about elimination, substitution, using graphical methods. And the fun part about question number 10 on a CSEC paper, when people see simultaneous equations, they forget they need to use a matrix method, and they go and they try to employ one of those typical methods that they would have used before. All right, so once you see question 10, once you know you reach question 10, people, matrix, you're always going to have to remember, once you see a pair of simultaneous equations in a question 10, it's a matrix method you need to employ. When we talk about simultaneous equations, these are what I refer to as linear equations, simply because we have two linear equations and they work together where they coincide at a particular value. So this system of linear equations will be extended into, like, well, obviously people were studying things like pure maths. If you go on to do further studies in mathematics in UE, you will be covering systems of linear equations. Yeah.
You see the stress we're going through already now with math. Honestly, do you think anybody wants that again?
I
Serious.
used to think I used to think that, but don't worry, don't worry, don't worry. In time to come, everybody's figure out what they want to do.
I mean, for the pure maths people, I see it for you all. Go ahead, go first if you wanted. But on my part, I'm not doing hard maths, so yeah, that's not for me.
So don't worry. Like I was saying, once you'll understand how to do this one, well, for people who decide to go further, you'll see it a little bit more. You'll have 3 variables rather than 2. So let's see what entails the system of linear equations problem solving. All right, so the first thing that we're going to do when we have a system of linear equations is recognize that they are a system of linear equations. So you notice here we have two simultaneous equations, both of them in x and y. So far, simultaneous equations, simple stuff that we are familiar with. Now, how are we going to use a matrix method to do it? Well, when we look at it, we just see a pair of equations, right? However, you have learned how to construct a matrix. You have learned how to create products of matrices. So these skills are going to be necessary when writing your system of linear equations in a matrix form. Okay, so let's take a look and see what that looks like. So just a quick reminder, in case algebra is very, very fuzzy, I mean, form 3 is like so long, and then form 2. Reminder, variable. Anytime you have an unknown quantity, you have algebraic letters involved, such as x and y. Those are variables. When you talk about a coefficient, you're talking about a number that precedes a variable. And when you talk about a constant, it's just a number all by itself. These terms are very important because when you are constructing your system of linear equations in a matrix method, that matrix product that you're going to create requires your understanding of who's a variable and who's a coefficient versus a constant. Because the first thing we need to know is that the system of linear equations, so this 2x plus 3y equal 29 and x minus 5y equal to minus 5, this system is going to be expressed in a form ax is equal to b. Okay, so we're going to take a look at the details. You'll understand what the a, the x, and the b talk about as we go along. So the first thing is the matrix of coefficients. So this is why I was saying we need to know the difference between coefficients and constant. The matrix of coefficients is that matrix A. And that matrix of coefficients will consist of all the coefficients in our system of linear equations. Okay, I repeat, matrix A is a matrix of coefficients. It consists of all the coefficients in the system of linear equations. So let's just take a look at our system again, and I want you all to tell me, what are the coefficients in this system? Anybody can tell me what are the coefficients you observe?
This would 2 be 1?
2 is 1. That's good. So 2 is a coefficient.
5 and
Anybody else?
3? And
Somebody
1
said
as
3.
well because and 1 as well because if
Right.
x is by itself, 1 is understood.
Nice. So I heard 2, I heard 3, I heard 1. I heard somebody say 5. Everybody agrees that the coefficient that we need, the final coefficient there is 5, or is it minus 5?
-5.
Negative 5, exactly. So we always need to remember signs. So good. So nice. See, you all already on a very good path, and I like that. All right. So if I have to construct my matrix of coefficients, first of all, let's take a look at this. How many variables do we have up here, people? How
Variables, we
many?
have 2.
2. Very good. We have 2 distinct variables. The next thing is this. We have 2 equations. So we're going to have 2 by 2 matrices when we talk about the matrix of coefficients here. So for this system of linear equations, our matrix of coefficients is going to be a 2 by 2 matrix because we have 2 variables and we have 2 equations. So when I create my matrix of coefficients A, this is what it looks like. So A is 2, 3, 1, minus 5. All right, and to remember how you create your matrix of coefficients, just remember the first column will have the coefficients for the variable x, and the second column will have the coefficients for the variable y. Now, remember, sometimes they might change up the variables. They might use PQ, they could use AB. Just remember, first column is for your first variable, second column is for your second variable. The next thing is your rows. So your rows now will consist of the coefficients from your first equation, and your second row will consist of the coefficients from your second equation. So that's why it was important to go back, take a look at the system, and identify all the coefficients, but also to remember where you found them. All right, because we know matrix multiplication is not commutative, so it's very, very, very specific in terms of where you put your elements into your matrix of coefficients. Okay, so everybody understands where this matrix of coefficients came from?
Yes,
Well,
miss.
this must have been from the thing that we saw before where we were calling out the coefficients. It's just from x and y, because 1 was understood with x. Then we have
Good.
2, -5 in the equation was also under y,
Mm-hmm.
and 3.
Right. So you see, that's what I was telling you. Once you look at your
It's
system,
more or less substitution. Would it be that?
well, it's not necessarily so much a substitution. It's more an identification and realization of your coefficients. So once you can identify a coefficient, you're good to go. Once you can tell the difference between coefficient, constant, variable, doing this piece is basic. All right. Normally, to express a system of linear equations in matrix form is about 2 marks on a test paper. So that's why, these nice little elementary steps, it's good to make sure you know it really well inside out so you have no trouble at all and you don't mess up and lose marks, easy little marks that you could get. So once we all good with where the matrix of coefficients came from, we can move forward now. So remember the format I said. Ax is equal to b. So we have a. The next thing we need to talk about is x. X is just simply going to be a column vector. All right, and the reason why I say column vector, it's basically a 2 by 1 matrix. All right, so it's just a column, and all this column vector is going to consist of is variables. So what are the variables used in my system of linear equations? So when I go back to the top and I look at my system, x and y. So my matrix x, or my column vector x, which contains all my variables, should contain all the variables I see in here. So because I only have x and y, my column vector x has x and y. So we have a, we have x. We're almost done with expressing our system in matrix form. So we have the equation part of things, I should say the expression part of things. Now we're going to talk about what was on the right-hand side of each equation. So you'll notice, so I just need to highlight this as well because sometimes they might mix up the order the equations are given in. anytime you look at your equations, always make sure they are given in this ax plus by equal to c format, where what I mean to say is you have all your variables on one side and you have your constants on the other side. Okay, this way it makes it easy for you to just create your matrix product and your matrix equation. So here our system is already nicely organized for us. We have all our algebraic expressions to the left and we have all our constants to the right. The things that we just got, the matrix of coefficients A, the column vector X, that product is going to give me everything on the left hand side. So now let's go talk about B, because B is just going to be a column vector of constants. Okay, so column vector of constants B is going to be a 2 by 1 column matrix because we only have two equations and each of them have only one constant. So this 29 on my first row, first column, this is the constant from my first equation. And this minus 5 on my second row, first column, this value is from my second equation. So the constant matrix, which is actually a column vector, like I was saying, this comes from the constants that the equations had on the right hand side. All right, so this is where this ax equal to b comes from. All right, so ax, everything on the left hand side, is equal to b. So everybody understands where we got the a, the x, and the b from? Anybody wants to go over where ax or b came from?
Yes.
Tia? Okay, I just
Yeah.
making sure. Need to check. All right. So yeah, again, signs are always going to be important. Once you start dealing with algebraic stuff, you always need to remember signs. Signs for your coefficients, signs for your constants. All right. So like I was saying, the matrix equation is of the form ax is equal to b. So you're going to combine the matrix of coefficients, your matrix of variables, and that is going to be equal to your matrix of constants. When you want to solve a system of linear equations, you are solving for x. You are trying to find a value for x. Okay, so this means that you need to do some sort of process to solve for these two. When you obtain your matrix equation, it's not to say that you're going to use that matrix equation and go and do back multiplication, because it's basically undoing what you would have done. In order for you to solve for your variables x and y, this is what you need to do. All right, so this is the process outlined in how we express the equation, right? The system of linear equations in a matrix equation form. So this is what we would write down. This is the system of linear equations we had from before in the matrix equation format. If I want to solve for my variables x and y, this is what I'm going to do. To solve this system of linear equations, we need to get the inverse. All right, and this is a property that allows us to actually find the solutions for a system of linear equations. So once, like I was saying, once we know how to express the system of linear equations in a matrix equation form, do matrix multiplication, and find our inverse matrix, we're going to be able to solve any system of linear equations via matrix method. So all this is just extra, 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 extra. So you all can take your time and read. But this was leading up to a very important fact. If I want to solve my system of linear equations, if I want to find out what are the values for x and y, A inverse times B is the format for the product that will give me the solution that I'm almost done. Just 5 minutes. Just 5 minutes, we're almost done. So y'all can take your time and go through all the details. But this is what I really wanted to show you all now. if you have to solve the system of linear equations, you obtain your inverse. You're going to multiply your inverse by the matrix of constants. And so look at it. I got my inverse matrix. So I have A inverse now. I'm not too worried about what is on the left-hand side in step 3 because this is just going to boil down to being the identity because I multiply the matrix by its inverse. What I'm concerned about is what is on the right-hand side, which is the product of my inverse matrix and my constant matrix. Finding this product, all right? So you all can go through the details as to, one, why it is we had to pre-multiply. Look at the statements involved in each step as well. Pre-multiply. Pre meaning before. You need to put the inverse matrix before B for a particular reason, and you all can go ahead and do that on your own time and figure out why that is necessary. Okay? The next thing is finding your product. Okay, so each step outlines how we went from matrix equation to answer. So you all are free to, like I said, go through your document on your own time. Take your time and internalize it. Need anything to clarify, just message me and we could sort it out. All right? But once you all can do matrix multiplication, once you can find the inverse, and once you can do what we just did, which is express a system of linear equations as a matrix equation, you're going to be really, really good with doing this part of things with matrix methods in simultaneous equations.